there are a lot of small operations out there, and those aren't just farms, but also small utilities. And it can be difficult from an economic perspective, from a technical perspective, from just a knowledge perspective to make the economics of those recovery facilities work. And so we're lucky to have a panel today to discuss how you can do that. And so I'm going to introduce Mr. Jeff Dawson. He's on our board of directors, and he's the CEO of Renewable Nutrients. Jeff brings to Renewable Nutrients more than 15 years of experience in the investment and capital markets industry. And as their CEO, he's responsible for overseeing the development and strategic planning of the company, including market exploration and opportunities for expansion. Jeff, I'm going to ask you, I know you've got a lot of stuff going on at Renewable Nutrients, and I was wondering if you could give us a quick preview or overview of any news you have, and then I'll introduce the other panelists.
Yeah, thanks, Matt. I'll give a quick update on Renewable Nutrients. As background, Renewable Nutrients is a commercialization company of nutrient recovery technologies. And we're currently licensed, we're exclusively licensed by the USDA to commercialize a number of patents they have in this space, a number of them in the phosphorus space and also in the ammonia space. So one of the things we're doing now is combining those technologies from a cost perspective to try and solve multiple problems in the same sort of value chain to try and make it a little easier to swallow in terms of expense, especially in the smaller markets. Our new technology is currently under design and construction at a municipal facility in the Midwest and a couple of waste energy operations in the Northeast, and we're in multiple conversations at sort of on the ag level. We have applications in agricultural, municipal, and industrial. Recently awarded an FLC award. FLC is an organization that basically combines all of the federal agencies and looks at their patented technologies that get commercialized. And this is our actually third award in that space for bringing technology to the market. What we're really excited about is that we're also expanding into the separations market. We're creating and manufacturing our own technical membrane for use in this technology. One of the issues we've had in terms of expansion is the ability to work with membrane suppliers to do this very specialized work. And we're acquiring pieces of a business and expanding on that so we can manufacture all of those technical needs internally. So that's where we are, and we're excited about this conversation.
Great, thanks, Jeff. So let me just introduce the other two folks, and then you can get started with the panel. So and also if Rick and Aaron could also turn on their cameras for this segment, if you haven't already, that'd be great. So Mr. Rick Johnson, Director of Commercial Development at Applied Environmental Solutions. Prior to founding that company, he retired from a growing tertiary treatment technology provider focused on phosphorus recovery. He's held a number of senior level research and commercial development positions with several Fortune 500 and Global 500 corporations. He owns a small family farm in northeastern Ohio, and is a graduate of the U.S. Naval Academy. Welcome, Rick. Can you hear me?
Yes, thank you, Matt.
Great. And then Dr. Aaron Fisher, Technology and Innovation Manager at the Water Research Foundation, another Alliance member. Aaron is responsible for identifying and evaluating innovative water technologies for their suitability to the LIFT program. He previously worked as a contractor to the U.S. Department of Energy, authoring the interagency document Energy Positive Water Resource Recovery Facility Workshop Report, and founded a startup commercializing polymer-based lithium batteries. Aaron, can you hear all right?
Yep, I can hear you. Thank you, Matt.
Okay, great. I'm going to stop sharing my screen so we can see your faces. And
I'll just suggest that folks in the audience turn on the speaker view, which might help them see the speakers a little better.
Yep, that's great. And I think I've stopped sharing, no? Yep, great. Jeff, take it away.
Great, thanks. This is going to be sort of a loosely structured conversation about applying nutrient recovery technologies at a smaller scale, and a discussion about the issues that revolve around that. And I think quickly, the three of us are each going to chat individually, and then we're going to sort of go back and forth in a discussion. But since I've already chatted about renewable nutrients a little bit, I'm going to hand over to Rick, let him talk. We'll let Aaron say a few words, then I'll come back and sum up, and then we'll dive into a sort of a roundtable discussion on the topic. Rick, you want to chat about an overview?
Yeah, thanks, Jeff. AES, Applied Environmental Solutions, we're focused on, we kind of bridge that gap between technology development, and also mass production, if you will. So we're involved in the commercializing of solutions primarily around the recovery of nutrients, and with a heavy focus on the agricultural sector. And to do that, you know, when Jeff and I first started talking about this program, this forum, you know, the question was, well, when you talk about small scale, that means two different things to me when I'm out talking to a farmer. There's small scale in terms of volume, and then there's small scale in terms of the level of phosphorus. So when you're dealing with let's say an anaerobic digestion stream where your phosphorus levels could be in the hundreds of ppm ranges or even higher, I've got to be able to address that issue. And by the same token, I'll go down the road and I'll be talking to somebody about a constructed wetland where the level of concentration is considerably less. So you've got to be able to address both of those, or that range of products or range of needs. And we currently have over 30 different farms in various stages of execution. Rebecca, I would thank you for the slides you showed of the bubble plots, if you will, of the Maumee River. Most of the farms that I'm dealing with are in the Midwest, and 4 states in particular, and they're heavily focused in the Maumee River area, if you will. So we've got over 30 different farms in different stages of implementation of a solution based around recovery of phosphorus. That doesn't include the wetlands. That doesn't include stream restoration or things like that. And one of the things you find is that each farm, while it may be unique in that it's got a different mode of operation, without getting too far into the weeds, when you start talking about a swine farm, to me it matters. It doesn't really matter whether you're dealing with a deep pit manure storage, a shallow pit, or a lagoon-based system. The end result is the same. Phosphorus is there, phosphorus needs to come out. And to further put pressure on that, there's a new NRCS 590 bulletin out there, which would be the equivalent of a new permit, if you will, affecting the amount of phosphorus that can be applied. So this is something that all of these dimensions enter in, all of these factors enter in, and we've tried to focus on not only providing a technical solution, but important to a farmer is going to be an economical solution. So.
Aaron, we'll hand it over to you.
Thanks, Jeff. Thank Rick. And thank you to Matt for the invitation to speak. I am here on behalf of the Water Research Foundation, which is a nonprofit that represents utilities across North America, actually globally as well, in terms of helping them pool their resources and fund research. So every year they pay an annual dues fee, and we take the funds that they've given to us. We work with them to determine what is of interest in terms of research, what's focused 5 or 10 years down the line, and we fund that research. So over the years, we have funded about $700 million worth of research, representing about 1,200 organizations, 900 of which are utilities, and a pretty strong overlap with a lot of the NACWA membership. So what they do with policy, we do a lot with research. I specifically work on the LIFT program, which is an innovation effort that we started here in the Water Research Foundation jointly with the Water Environment Federation. Obviously recognize that research is a very big part of what the utilities are interested in, but taking research and implementing those ideas requires a different set of skills and a different set of support network for the organizations. And so we built the LIFT program to help utilities go through their innovation journey as they find innovation, see innovation, try innovation, ultimately do innovation, and then share that with their peers. Obviously, representing a lot of utilities, we tend to have focus. The membership tends to be more of the medium and larger utilities. But in terms of phosphorus recovery, there's two things I can talk about. One, why utilities are looking at these ideas, and two, what my actual role is largely being a technology scout, seeing what I've seen out in the landscape. And I'm sure many of you have seen some of the larger technologies. We've started to see some interest in downscaling a lot of these ideas to work with not only small treatment works, but also at CAFOs. And it's because obviously the amount of phosphorus that's generated is sufficient to find beneficial economic purposes down the road. And so vendors certainly have started to look at, and innovators to look at, downscaling some of the ideas that they've done at a much larger scale. But in terms of utilities, why they have looked at implementing, as Chris aptly noted, the policies around taking the struvite and doing anything with it are not they're not set up to allow for that to really happen. And so what the utilities have started to realize when they've looked at struvite recovery is that getting phosphorus out of the water stream, out of the solid stream, particularly helps with the dewatering. And so taking a couple more percentage points of phosphorus out ultimately helps reduces your polymer usage, directly reduces costs, allows you to get a drier biosolid. So when you go to haul it, you pay based on weight, not based on nutrient content. And so the less water that's in there, the cheaper those costs are. And because that is among the larger costs and operating costs at a utility, they have been very interested in any solution that can reduce their phosphorus in the biosolids. And struvite recovery certainly has demonstrated that, along with the number of brushite recovery. They've all demonstrated that, and that has been a very big driving factor for the utilities. They've been able to build a business case around that while waiting for the regulatory authorities to really recognize that struvite is not really the same as biosolids and shouldn't be subject to the same regulations that they have subjected biosolids to. I'm going to stop there, and I guess, Jeff, we got a lot of questions. So,
right. We'll keep going. So, one of the things that we deal with in this space as a company, and a lot of private companies who are trying to commercialize technologies deal with, is the first question is always scalability, and the obvious question is, can it be scalable up? Well, when you take a new technology, everyone's worried about how large it can get, how reasonable it can be, and the larger you can scale it, the more economical it is. The problem here in this space is that the problem we have with phosphorus nationwide here is that it's a problem that's scattered among different organizations, different companies, different facilities, and those are primarily very small operators. There's 16,500 municipal facilities in the United States. 85% of them are under 1 million gallons a day. So while they're dealing with the majority of the problem, they're too small to deal with some of these more costly providers of nutrient recovery. So we're trying to find ways holistically to solve problems that can deal with those issues. One of the things here is that the things we can talk about is the challenge that even farmers have in terms of investing capital and taking risk. Rick, you deal with these folks every single day of the week, and while it may not be as simple, they want to get into the fertilizer business. They certainly do want to be in a place where they can, if they look beyond the value of fertilizer, they may be able to come up with solutions to solve some of these land application problems.
You're right, Jeff. And really, ultimately, from a farmer's perspective, when he's looking at needing to invest in what he's going to consider infrastructure, phosphorus recovery or phosphorus reduction, he's trying to answer a question. Am I better off spending, pick a number, $250,000 on a solution to a manure problem, or am I better off investing in another tractor? So everything is viewed through those set of optics. And, to try and, I've seen many people go out, dealing with farmers, and they try to address it from we're going to make this a better world. And while that's true, it does help. From a farmer's perspective, he's purely looking at what's the best use of my money that I've got, number one. Number two, you also have to recognize that assessment's going to be changing over time. Last year, for instance, was a very wet spring, as I think most of us in the U.S. know. And consequently, a lot of farmers were not able to get their crops in. Well, the average consumer will think, well, that's going to affect prices in the grocery stores. And that's true. But from a farmer's standpoint, it affects his ability to land apply or to center pivot irrigate next year. Because the amount of water that he can put down, the amount of phosphorus that he can apply to that land is directly tied to how much was taken up the year before. So if you have a wet spring the following year, he knows he's going to have to deal with issues. I'm working with farms right now that I mentioned those 30 farms. 4 of them right now are having to truck water to a municipal wastewater plant. And they're having to do that because they're not permitted to irrigate with it this year because of last year's spring. Well, if you do the economics, they're paying 8 cents a gallon to transport a mile or 2 down the road. If I can give them a solution for a penny a gallon or 2 cents a gallon, that's going to be a better investment from him.
Rick, you and I have worked on projects where we've modeled things out, and when we get beyond the simple equation of how much byproduct we're creating and the value of that byproduct, and you go into fuel for the distance traveled for transportation, you go through being able to use some of those value streams on their own property. If a farm does agriculture as well as animal operations. And one of the things we found is we had to sort of go down an entire scale of 10 or 12 price points, and you get to at one farm, we got to the point where the cost of insurance for transportation biosolids over public roads was so high that we were able to eliminate that, and the model worked. So you have to sort of get beyond sort of a basic conversation when it comes to really small operators. And Aaron, I want to bring you in here a little bit. One of the questions you sort of proposed was, is there a business model for innovations that might help with the deployment of small scale? Can we do this by working with farms jointly? Can we do a centralized location and sort of make it a larger scale? I'll throw it out to you to have some comments there.
Certainly. In terms of business model innovation, I think the largest push is when you look at some of the models that you were talking about, it's the capital cost versus the operational savings and trying to find that break-even point. And a lot of folks have seen that and recognize that as a potential barrier to a lot of these opportunities. And so there's an opportunity to capture the value between the capital cost being depreciated and the operational savings. And that usually is most people talk of those as a service. So software as a service, infrastructure as a service. Certainly all of those models come into play, because if somebody can underwrite the upfront capital, because as Rick noted, absolutely, like farms are not drowning in money. They might be drowning in water, but they're not drowning in money. And with the number of limited choices you have to make, if you can put something into an operational or an annual budget, the calculus becomes very different in terms of embracing some of these ideas. And it's not that farmers are hostile or not resistant or not willing to embrace something that's more sustainable. It's just at a certain point, they're running a business. And until you can get through all of those options or really give them enough cash that they can really make a sound investment for the future, sometimes you just got to look at what they can do right now. And so those as a service opportunities have certainly looked at changing that calculus, changing that and putting that capital cost into an operational cost and then capture that savings. And so suddenly, if you had said that trucking was 8 cents a gallon or the total cost was that, and yeah, maybe you could get it down to a penny a gallon if you own the system, but if you're at 6 cents a gallon, you're going to take that too. And so just recognizing that simple savings and capturing that and then offering those services. I don't know if I've seen anything that quite does that, but certainly where there's money to be made, there's businesses to be started.
Agreed. Yeah. And, one of the things we've modeled out is the ability to sort of mobilize the technology. So rather than build a standalone facility at a single operation, do we have the ability to do this on a scale small enough where you can mobilize it, operate it over a period of time at a site, and move it along? We did some piloting on that in North Carolina at some swine farms, and the reality is they do most of their operations that way. They operate for a sort of an intense period of time at a facility for other things, and then move to another facility, especially if somebody owns multiple farms. So we're working on a small scale model there. The other thing that we were able to do is we sort of look beyond, and this was from a client's recommendation, to look beyond fertilizer, and we can extract phosphorus in the form of struvite, but we can also do it in the form of calcium phosphate. And in the animal feed world, you can actually recover that calcium phosphate and refeed it, re-put it back into their feedstock, which changed the paradigm on cost for them whatsoever completely. These farms didn't necessarily want to be in the fertilizer business and didn't necessarily have use for fertilizer on farm. But when you talk about having to be able to recover that in a usable form for feedstock, that cuts down on costs on both ends of the operation, no pun intended. And so you have to sort of do a little bit of a paradigm shift on the modeling to sort of make this work. And I think you'll see that over the next 5 or 10 years. There'll be a number of those.
Yeah, and Jeff, this is Rick. Just another add-on to that point. Typically, when you're dealing with an agricultural setting and you recover phosphorus, we like to recover it in the form of amorphous calcium phosphate, but you also end up with a second product, the lower phosphorus water that's left over. Now, unlike a traditional industrial or municipal application where you can use it for some things, a farmer looks at that from two different perspectives. Number one, if he can use that water to irrigate and he can get another crop rotation in, that's real money to him, number one. Secondly, we've been able to show that by reducing the amount of phosphorus and consequently the lower phosphorus water, irrigation water, in some of the models we've done in a typical 3-crop rotation, we've been able to reduce the amount of acreage that's required by about 40%. In other words, they can put more water down for the same size acreage and get more crops out, and at the same time reduce the loading in terms of phosphorus. That's something that means something to them. It's a way of translating that secondary product into a value stream for them.
Aaron, one of the questions we have thrown out is how will precision agricultural and advancements in land management, which reduces the need for P and other nutrient, impact the economics of small-scale P recovery?
This was more me thinking 5-10 years down the road, but certainly with the precision, the movement towards precision agriculture. I mean, you started to see a lot of Silicon Valley suddenly come to the Corn Belt and
right.
Just go, we have all this GPS stuff. I mean, you guys are running your combines off of GPSs already. They're not doing, and so understanding where to put things down and maximizing the loading of a specific square foot, not a specific acreage, a specific square foot, and then that way you can get it down, and then in the marginal lands that abut kind of rivers and streams, and don't put down the phosphorus there because effectively it's just going to flush away. I mean, this is the farmer. I mean, directly he pays for the nutrients, he pays for the phosphorus. I mean, that's his fertilizer or her fertilizer. And certainly if you can use it wisely, use less of it, I mean, certainly that's another value stream. And so that's my thinking. I don't know if I'm just thinking out loud though.
Right. Well, I mean, earlier there was a question raised: is the byproduct more transportable? And I would argue that we're looking at it two ways here. It's not just more transportable, but it's also you can store it. So if the farm is small enough and it's seasonally operated and they need phosphorus applications at periods of time, yet they have to land apply their cleaner water all year round, not only can they, apply the biosolids and water phosphorus free, but they may be able to store that byproduct, that struvite or calcium phosphate product, and use it at a certain time of year where it's needed. Or again, it is more transportable, so they can move it across state lines or across different farms where it's needed. And that goes back to knowing the nutrient properties as tightly as you can on land use. Rick, what are you saying in terms of the conversation around farms coming together as sort of a joint operations and the challenges there for regionally based nutrient recovery versus on farm-based nutrient recovery?
That's a great question, Jeff. And actually, there's two aspects. You touched on one of them regarding the mobility aspect. Having a whether it's owned by a co-op or a district of a common tool that can go from smaller farm to smaller farm. What I've been seeing more of is a growth of community digester projects. And one of the programs I'm working on actually involves 23 different farms transporting manure to a central location. And, that gives us a tremendous advantage in terms of scale. You've got some tremendous logistic questions because you're combining swine manure and dairy manure and you want to keep them separate within the digester, but those can all be managed. And that to me is a trend that we're going to see more and more of. I have two of those programs going on right now. So I think we're going to see a growth of that type of an approach as long as there's interest in converting methane or reusing methane gas.
Right.
I see the trend continuing.
Okay. All right, Matt.
Yeah.
You want to maybe open this up to some questions? And
Yeah, let's do that, Jeff. If people want to raise their hands and ask questions of the panelists, I can go ahead and select you and unmute you as you come through. Otherwise, I'm sure, Jeff, you guys could go all day, right?
Yeah.
This is your favorite topic.
It is, and again, as we deal with smaller scale facilities, you sort of have to think out of the box in terms of the value presentation here, not just in the byproduct, but in their ability to meet certain needs. For instance, the value may be in internal operations and maintenance with regards to struvite buildup. And it may be a simple equation there that there may be a problem that the byproduct, the value of the byproduct, while it may not pay for everything, it may when you include the value of the savings and operations in other areas, including dewatering, which changes everything when you're reducing the number of loads going out of the back end of a facility.
Yeah, it's great.
Jump in with a question while we wait for others to raise their hands. So that was great, and it's exciting to learn all these things. So maybe a question for Jeff and Rick is sort of like, we talk about the regionalization of the manure production, and then the idea of providing this treatment and recovery as a service to farmers, et cetera. So one model is, everyone has their own device or their own facility. Another one is people move the manure to a regional facility for treatment. Are those the only two options? Is there an option where you take the facility to the farm, where you tow some big piece of equipment around, a bioreactor of some kind? What are the models that are out there?
So the third model is you do a small scale operation where you bring to the farm and you move it from farm to farm. And one of the places that may work is when you've got a large farming operation that's divided in multiple sites. So you may have a couple of hundred farms, you may have 50 farms, whatever the number is, but yet you have a principal place for feedstock, and you mix your feedstock at a certain place. If we could then combine all that byproduct at one location for redistribution based on a sort of a mobile application of the technology, then I think that in itself maybe that third model. So, you either scale down the delivery of the technology at a location that's affordable. You scale it down to mobile, where you can take advantage of that capital at multiple locations, or you scale up the waste stream and you bring it to a centralized location. And somewhere is this sort of crossover of value, right? And that's sort of what we look at every day. So
that's fascinating. I see some questions have come in, so let's go.
Yeah, they do. And I just remind everyone that the chat is open as well if you want to converse amongst yourselves. Alex DePillis, I'm going to unmute you.
Hi, everyone.
Hi.
Great session. I think what I've been hearing from farmers here in Vermont is they would love something that would give them half or maybe 70% of the phosphorus that the dairy manure starts with, and keep all of the nitrogen. And so I've been thinking about, is there a sort of a lower removal rate, lower cost kind of technology, like a screw press that has some polymer added, or a lot of people are adding biochar and then skim that off, or I'm hearing a lot about technologies that have an 80% removal. I'm looking more like for 30 or 50% removal and not a lot of money. And by the way, the mobile stuff is pretty interesting. Penn State did a whole big trailer, the Mafex trailer, to remove phosphorus and nitrogen. Interesting stuff. I don't, again, if someone's going to commercialize that, that might be the answer to my question. Thank you.
Yeah, I'll address it a little bit. We have a mobile facility now currently going from site to site. We've designed other ones, certainly that are more appropriate for end users, specifically for their issues. But in terms of recovery, you're right. At least with our renewable nutrients technology, Quick Wash, it's scalable in terms of the volume of phosphorus recovered. So while we can go up to, over 90% of the phosphorus recovered, on the ag level, on the farm level, that may not always be the desire, right? So the value may be that, hey, we don't have to take it all out. We only have to have 30% of it out, or 50 or 70, whatever that number is, it's sliding scale number. Well, the amount that you take out directly affects the cost of operations of the technology. So if you have to take out less, it's just a better, financial model from an operations standpoint.
Yeah, and Alex, this is Rick. From my experience in talking with farmers and working with them, and also working with the Mercer County Ag Solutions Group, which is a group in central Ohio, central western Ohio, that's done a lot of work focused on dewatering of manure. You can indeed achieve a less volume or less percentage, a lower percentage of phosphorus reduction through dewatering, but you have to look at the total cost. And while you're going to spend just as you may spend more, if not similar amounts in terms of capital, your operating costs are going to be influenced by the use of polymers. It's while it really boils down to what's the individual want to do. If they're what's their value proposition, if you will. If they just want to get under that radar from a phosphorus load, that's one thing. Having worked with farmers in Vermont, if they can view it as a exportable product, dried phosphorus or recovered phosphorus as an exportable product, there's a value proposition there as well. So yes, you can get lower. I will typically, the lowest that I will usually reach is 70% with dairy. But I've gone as high as 95%. And again, it really depends on the economics and what's driving the decision and the interest by the farmer.
Great, thank you. We've got another question here from Laura Campbell.
Can I quickly add a comment to Rick's?
Sorry, didn't mean to cut you off there, Aaron.
No, sorry, Matt. Sorry, Laura. I just wanted to quickly add, one of the other technical challenges with recovering a smaller percentage is oftentimes pH is a very common way that the phosphorus is separated out, and it's very tough. pH does not change in kind of a linear fashion. Often you're adding a strong acid or base, and it changes in a very stepwise function. And so at a certain point, once you hit the magic value, you're already there. It's not so just a quick thought. That's not every mechanism, but a lot do work with pH.
Right.
Great. Laura?
Thanks, everybody. And I appreciate this discussion. Kind of tying back to what we were hearing earlier about some of the regulatory challenges with struvite. One of the regulatory challenges we've hit on here, and I'm speaking from the perspective from Michigan, is that we're finding real challenges with being able to cite, for instance, a digester that's going to be receiving materials from multiple farms, or is going to be receiving different types of feedstock, you know, so a combination of manure and food waste or something like that. And I wanted to see if there's anything in your experiences for the different technologies and products and you know, sort of scalability that you would provide as either advice or, hey, this happened to us, or this is a challenge here too. These are things that needs to be fixed in terms of that regulatory burden.
Hi, Laura, this is Rick. You're bringing up a very good point. One of the large community digester projects that I mentioned is in Michigan, and we're actually going through Eagle review right now. So yes, Michigan has some unique challenges, just like Ohio would, or Illinois, or Indiana, or Toronto, or excuse me, Ontario. So much of it is just understanding what the requirements are and their expectations are, what's the basis of their question. And we're just approaching it from a scientific and a practical and agronomic standpoint with them. And so.
Just to quickly add on to Rick's point with community digesters, and when you talked about food waste and different sources of feedstocks, obviously with the RINs and the LCFS, or more particularly with the RINs, EPA has kind of taken an all or nothing approach that manure, wastewater solids are fully within the higher level. I think it's D5 RINs or D3 RINs, excuse me if my number, it's whatever the better one is. But then if you use food waste, you automatically then have to figure out what portion of your natural gas or your methane, your biogas is due to which feedstock. And that is a really detailed calculation that, I mean, even advanced modelers have a really tough time figuring that out. And suddenly now you have to count all of it as the lower RIN credit. And it's really, we're certainly working with the regulatory agencies from a scientific perspective to help them understand that what they're saying is they're working in a binary black and white world, and that is not exactly how the rest of the world works. It's a little bit gray. It's a lot of grays.
Yeah, I think I agree with you, Aaron, that what we're seeing is that the issue isn't combining different animal feeds into a digester. The issue is when you start blending beyond animal into food waste, then it becomes a bit of a mess.